All right, what's up guys? How's it going? So for today, we are moving on into Unit 5, which has to do everything with right triangles. So we've done everything up to doing some similarities with right triangles, all the way up into using the Pythagorean theorem. So today we are focusing on something called trig ratios. So trig is short for trigonometry, which is a higher math that uses geometry and some more types of mathematics. But today we're focusing on trig ratios. And the one that we're going to look at today is something called sine. And what this is used for is if you are given one of the angle measurements of either A or C right here, you can use a trig ratio to help you to solve for a missing side. So for example, you guys need to remember that sine is always going to be opposite over the hypotenuse. So the sine of whatever angle you have is always going to be opposite over hypotenuse. So for example, if we knew the value of angle C right here, let's just go ahead and say we knew the value of angle C. Right now, automatically, we know the side opposite of the right angle is always going to be your hypotenuse. So this guy right here is always going to be your hypotenuse, correct? Okay? So now, let's say hypothetically again, we knew angle C. So automatically, I knew that the opposite side is going to be opposite of angle C. So right here, ladies and gentlemen, this is going to be known as the opposite side from C. And then right here, this side right here is going to be known as the adjacent side from C. Okay? So right now, we could actually look at this and see, okay, so if I wanted to find the sine of angle C, then I would do the opposite, whatever this guy is, over the hypotenuse. And that's how that guy would work. So ladies and gentlemen, this is sine is opposite over hypotenuse. So I could actually do the same thing going from angle A. So right now if I went ahead and erased this, and let's say hypothetically, ladies and gentlemen, that we knew the measurement of angle A. The hypotenuse is never going to change. It's always going to be opposite of the right angle. So if I took this and I did this, I went from angle A, opposite of angle A, so now this would be the opposite, and then the other side that's missing would then become the adjacent side. So ladies and gentlemen, I would then take the hypotenuse, I would do the sine of A, I would take the hypotenuse and put it on bottom, and then I would take the opposite and put it on top. And then I would be able to solve that and figure out what would be the actual mathematics behind this. Okay? All right, so here we go. So we got two examples, and we're going to use the sine ratio to do this. So remember, sine is always going to be opposite over hypotenuse. Okay, so here we go. So right now, in example number 1, we are given a situation where we have a flagpole here. So what we're going to do is we are going to use the sine ratio to help us define the height of the flagpole. Okay, so here we go. So right now we notice we are given, this is a 90-degree angle, and we're never going to use the 90-degree angle with any of the ratios. We're always going to end up using either this angle or which one's given. So right now, angle 50 is the one that is given to us. So we're going to be looking at everything from this angle. So right now, ladies and gentlemen, if we look here, I'm going to go all the way across, and this is going to be my opposite side. And then opposite of the 90-degree angle is obviously going to be your hypotenuse. And then if you wanted to, the third side is going to be adjacent to this angle here. But right now, we need to find the opposite side. So we're going to represent that as x, and we are given the hypotenuse. So right now, since we need to find the opposite, and we have the hypotenuse, I now can use the sine ratio to help me define this. So I'm going to use sine is going to equal opposite over hypotenuse. So let's go and plug everything in. So what I'm going to do is I'm going to do the sine of 50. So I'm going to do sine 50 is going to be equal to the opposite, which is x, over the hypotenuse, which is 20. Okay? And so now literally all I have to do now, ladies and gentlemen, is solve for x. So right now, x divided by 20. So the opposite of dividing is multiplying. So I'm going to multiply both sides by 20. So I'm going to multiply both sides of my equation. I'm going to put it down here. So I'm going to multiply by 20. Okay? So right now, this is going to cancel. So on this side, I'm going to be left with x. And then in my calculator, you are actually going to go to your trig functions, which should be right underneath your control button. And you're going to do control, you're going to click sine, and you're going to do 50. And then you're going to multiply sine 50 by 20. And so this is what it should look like in your calculator. Sine parentheses 50 times 20. That's what should happen in your calculator, okay? And whenever I click enter, you should get 15.32. And we're going to round to the nearest hundredth. So right now the height of the flagpole is actually going to be 15.32. Done. Okay? All right, and so now in the next example, we're actually going to use the opposite of sine. So what that means is we are going to use the inverse of sine, which looks like this guy. And I'm going to show you how to do this. So right now, we are also going to use the sine ratio to help me to find a missing angle. So right now, ladies and gentlemen, I want to find the measurement of angle B. I do not know the measurement of angle B. But what I do know, if I look here, if I go all the way across, opposite of B, this is going to be your opposite side. Opposite of the right angle is always going to be your hypotenuse. And then right here, I know that this side is going to be my adjacent side, but we're not worried about that right now. We'll look at that in the next video. So right now, if I look here, I want to find angle B. So I know the opposite side, and I know the hypotenuse side. So that matches opposite over hypotenuse. So to find the sine of B, I'm going to do the opposite over the hypotenuse. Okay? And so now, sine of B is going to be equal to, the opposite is going to be 1.5. The hypotenuse is going to be 4. And so now, right now, I need to find angle B right now. So in my calculator, you're going to go back to the trig functions, and you're going to select sine inverse here. So I'm going to go to my calculator, I'm going to click trig. I'm going to go sine to the -1, which should be right under sine. And what I'm actually going to do is I'm going to type in this ratio. So this is what it should look like in your calculator. Sine, -1, and in the parentheses, I'm going to do 1.5 over 4. And so I'm going to do that in my calculator, so 1.5 over 4. And when I click enter, you should in return get 22.02. So that is actually going to be the degree measure of angle B. So the degree measure is 22.02. So ladies and gentlemen, this is a brief explanation of how to use the sine ratio.